Hello, everyone, and thank you for joining us today for a Learning and Growing webinar using Excel in the math classroom. Our presenter today is Professor Kevin Weaver of Pacific College of Health and Science. My name is Victoria Kelly, and I'm a member of the Hawks Learning Customer Support Team. We will have a live Q&A question session at the end of the presentation, so please enter any questions that you may have into the Q&A or chat box as we go. And on that note, I will now hand it over to our presenter.
Thanks, Victoria. Is my screen still being visible?
It is, I think you need to try sharing it again. It's not showing on my end.
Okay, I have to find the right control here. There we are. How about now?
It is now. Thank you.
Great. Do we have anyone else in the webinar yet?
Yes, we do. We have 6 attendees.
Great. Okay, well, then let me talk to you all. Thank you for joining in. And I want to first point out that I use Excel 365 when I teach the various math courses that I teach. And while most of what I will show, if not all of it, can be done in the earlier versions of 365, but 365 is so powerful and has so many great features that I tend to stick with 365. And at the college where I currently teach, the college provides 365 for free for all of the students. One of the things that I use in a math class is to have students work with quadratic equations. And I want to point out that I don't teach Excel per se. I teach the parts of Excel that are necessary to do the things that we are doing in the class. So while I give an overview of Excel in the beginning, I then go into the math issues and talk about the math issues, and then introduce parts of Excel that are necessary to get the point across. So here is a case where solving a quadratic equation can be done in a number of ways. If we look at the standard form of a quadratic, and we use the quadratic formula, I have students program or write the formula for solving the quadratic using the quadratic formula. And if I click on the B13 cell that has the root for the first X value, you can see that that rather ugly formula at the top on the formula bar shows how to calculate the quadratic formula. And I'm going to pull this up and just make sure that you can see that right here. And essentially what it does is teach the students how to write the quadratic formula and how to analyze it by doing the negative of the B coefficient. And then it's plus the square root, and then divided by 2a. And if you then look at the next cell, you'll notice that it's exactly the same formula, but in this particular case, it was changed to minus, since the formula is plus or minus the square root. The other thing that I then make sure they know how to do is to find the discriminant. And so I have them program b squared minus 4ac. So in this particular quadratic, which is x squared plus 8x minus 33, the discriminant is 196. Then I teach them how to use an if statement in Excel to determine the nature of the roots. whether there are 2 reals, no reals, 1 real, etc. And they program that to analyze a variety of possible quadratics by looking at the coefficients, calculating the discriminant, and then using an if statement to calculate and determine the nature of the roots. So basically, this can be done with any version of Excel. The next step, while it can be done in other versions, earlier versions of Excel, is really streamlined in 365. The next thing I wanted to do was to have them appreciate the fact that it's a parabola and look at the graph of the parabola, which of course, then they need to have coordinates. And in order to come up with a range of coordinates, I use a feature in 365 that's called sequence. In earlier versions, you could just type in -7, -6, -5, and select that and fill it down in the X coordinate column, and that would work. The sequence function in 365 is really souped up. And what it allows you to do, if I go up to the formula bar, you'll see the little tip. The first argument of the sequence function is how many rows do you want? And because I wanted to have a 0x coordinate, I picked 15 rows. The next argument is how many columns would you like? If you don't specify it, the default is 1, which is what I wanted in this case. And then the third element is where you would like to start the count. If you don't put that in, the default is 1. But I wanted to start it at -7 and then go up using 15 values so that I could get from -7 through 0 and then up the integers to 7. The last argument, which is another optional argument, is how you would like to step the increment, which by default, if you don't put it in, is a 1. And so the sequence function immediately uses something in Excel 365 called a dynamic array. And what it does is it immediately fills in the X column with the numbers from -7 to 7, incrementing by 1. Then we program the Y coordinate by simply taking the corresponding X coordinate, which is in F24, and squaring it, multiplying it by the first coefficient, adding that to the X value times the second coefficient, and adding that to the third constant. And then after selecting all this data, the students would then go to the Insert tab, and in this particular case, would select a scatter plot. And the scatter plot, I would like to have the points on it, and I would also like to have it be curved. So you see it looks like that. And so I already did it, and there is the makings of the parabola. I also have them calculate the vertex by using the formula -b over 2a, and that calculates the X value. Then by substitution, they can calculate the Y coordinate. And what's nice is that it reinforces them if they hover the mouse on the point. When they do, you'll notice that Excel says that I'm looking at this point, which is -4, -49. And that, in fact, is the vertex. Pretty simple and very straightforward. And then all they have to do, because everything is dynamic, is change the coefficients. For example, I could use the first one, which is 6. I'm not in the right place. I want to be in this cell. And that is 6, -13, -5. And everything dynamically changes. And there is my new parabola. Since a picture is worth 1,000 words, whoever said that, I put a lot of emphasis in my classes to use graphing, whether they're working with linear functions or quadratic functions or higher degrees. And they can then get an appreciation for what is happening with the particular equation, whether it's linear, rising to the right, whether it's linear, rising to the left with a negative leading coefficient, or looking at a parabola. And of course, once again, I used the sequence function, which is dynamic, and it fills in this particular set of examples, 11 values, one column, starting at -5 and incrementing them by 1. I could have left out the 1 if I wanted to. The very interesting process to explain to a math class is working with matrices. Working with simple matrices and simply adding them together or subtracting one from the other is very straightforward because it's element by element. But matrix product tends to be an issue because there's a lot going on. There's a product, and then there's a summation. So the nice thing about this is that Excel has a feature called matrix multiplication. So if we took a look at this fictitious set of data where I have the sales quantities of 3 different pies for 4 different days, and then I have the price of those 3 pies, $3 for apple pie, $4 for cherry pie, and $6 for pumpkin pie. And what I'd like to do is to get the total cost on a day-by-day basis for the 3 different pies. So what is happening here is that I am going to be taking a 1/3, that is this one, of the cost, and multiplying it by a 3/4, which is this one, to get the matrix product. And it has a matrix product because the inner dimensions, the number of columns in the first matrix, is equal to the number of rows in the second matrix. And when it does the matrix product, those are collapsed, and the answer will be a 1/4. And so here is my matrix product, which is also dynamic in that I simply have to tell it to use the M-mult for a matrix multiplication. And the first argument is the first matrix, which in this case is the price range. That's the 1/3, comma, the second argument is the quantity matrix, which ranges from C2 to C4. And once I put that in, Excel does its magic, and I get the prices. On Monday, there was $107 worth of pies being sold. Tuesday, $79, and so on. The other thing that's important when working with the matrix class is to have them calculate matrix inverse. And again, we'll use Excel as the crutch, and it has, as you can see from that cell and up in the formula bar, it has a function called M inverse, and it will find the matrix inverse if it has one. If it doesn't, you'll get an error message. So in this case, I want the matrix inverse of the table just above. That is a 3 by 3 containing 0, 2, 3, negative 9, 6, 8, and negative 3, negative 4, negative 1. And there is the matrix inverse with outrageous looking numbers, of course. But then the next move is to calculate what the matrix product would be of the original set of data and the inverse. So now what I want to do is take the matrix multiplication of the 3 by 3s. Now I teach one more thing about Excel 365. Actually, two more things. The matrix multiplication is to take the product, the matrix product of the matrix in C16 through E18. That's this one. And multiply it by, using matrix product, the inverse, which is this one. Because it's dynamic, if I show you the matrix inverse, the formula is in the C20 cell. And then I make sure the students realize that because 365 is dynamic, what it does is that it just spreads the information elsewhere. And how you can tell is by moving the cursor to another cell and looking at the formula bar. In D20, the calculation was done, but the formula is grayed out because it's not really there. It's a dynamic calculation using the formula in C20. In order to reference a dynamic calculation, you can see that the reference made is by putting a hash mark after the cell that has the dynamic formula. So I don't need to write C20 colon E22, which is that range. In fact, if I did, Excel would correct me and quite politely point out that the formula is really in C20 and it was dynamic. And so it really could be abbreviated as C20 hash mark. And it does the calculation. Now, if you look at that calculation, it's really ugly. And you can see just how ugly it is because it's right here. So the question is 2.78 times 10 to the negative 17th, is that close enough to zero for your work? Well, it is. It's really a zero. And in order to get the zero to actually appear, the function that's used is truncate. So I could truncate the result of the matrix multiplication to one decimal place. So in this particular case, it eliminated all of the decimal parts of this ugly calculation over here and produced an identity matrix. As kind of a sidebar in teaching this, I point out that there's another function relating to matrix operations, and that's called M-unit. And this will generate an n by n identity matrix depending on n. In this case, I called it a 5. So it's a 5 by 5 identity matrix. If I wanted a 4 by 4, I could change that to a 4, and you'll notice that M unit of the value that's in L18 then dynamically creates the 4 by 4 identity matrix. So that is how I teach matrix multiplication, matrix inverse, and then to use some other things like creating an identity matrix. One of the classes that I teach is called Quantitative Reasoning. It's a class that's taught to students that are in a Bachelor of Science class curriculum at the college where I teach, and they're majoring in public health. The class has a heavy emphasis on large databases and then statistical analysis of large databases. The students are doing projects where they pull a large database from the CDC, for example, and they look at results from the CDC's studying COVID, for example, where they're studying other diseases. And then they want to analyze the databases statistically. So they immediately learn measures of central tendency. The typical 3 would be the mean, also called the average, the median, and the mode. So we usually start with setting up a simple database of only a few numbers rather than hundreds of them, but to see how it applies. In Excel, for some reason, they decided to use something called average rather than mean. I don't know why, but they did. So the mean and the average are calculated on this data set by typing equals average. And the argument is the range of data. To calculate the median, the explanation is that you're looking for the middle number when the data is sorted from low to high or high to low. If there's an odd number of values, the median is dead center. An even number of values, the median is the average of the two in the middle. But after explaining that concept, I point out that Excel handles the sorting and it handles the averaging as necessary. Because we're not really teaching how to sort the values, and we're not really teaching how to calculate the median by taking the average of the middle two. The concept is, what is the measure of central tendency? It's median. We need that value, and that's available. There are two ways to calculate the mode. One way is if there is one mode, and that function is called mode.sngl for a single mode, the number that appears most frequently. In this case, it's 54. If I change the data set so that in this particular case, it has 12 elements, 3 of which are 54, and 3 of which are 60. To play it safe, I could use mode.mult of the data set And this, once again, is a dynamic array, and it calculates the multiple mode of 54 and 60. And notice that because it's dynamic, the cell that shows the 60 is grayed out in the formula bar because the formula is not really there. The formula is in G3, and it just spills over into the next cell in G4 and calculates it. And you can see it's dynamic, that if I change this 56 to a 57, there are now 3 of them that occur 3 times, and it immediately calculates all 3 of the modes, the 54, the 57, and the 60. Now, the killer in that class is calculating standard deviation. And it's a killer because it's a horrendous process. And I point out to the class just how horrendous. And in fact, so that they have an appreciation for the standard deviation, we actually go through the horrendous process. The first explanation is that it depends on whether your database represents the entire population. Maybe the CDC has a database on COVID in the United States, or whether you're looking at analyzing a sample from the population, like maybe COVID in the state of California, where I live. So there are 2 formulas. They primarily differ by dividing by n or n minus 1. So we play the horrendous game. And in this particular case, in my first example, I've used a very simple block of data. The mean is the average of that block. But then we calculate the deviation from the mean. So the deviation from the mean is going to be this value or this value, which are each of the data values minus the mean. Well, that's rather straightforward. If you say it to yourself, it is each of the data values, they're in B18 through B23, minus that static value, which is in C18. And again, Excel is dynamic. It calculates the subtraction for all of them and fills in the deviation. Then that column has to get squared, and notice the hashtag. D18 has the dynamic formula in it. So I just simply want the D18 dynamic formula raised to the 2nd power. I get the answer. Then I want to find the sum of the squares. That's a simple one using E sum. Then I need to divide that sum by, if it's the population, n. In a large database, I certainly don't want to have to count them. So even in this small database of 6 numbers, I use an Excel built-in formula called count A. That counts how many values in the range are numbers. If it is the population, I'm dividing by n. If it's the sample, I'm dividing by n minus 1. And now you can imagine the groans that I get from my students. said, oh, we're going to have to go through this mess, even though Excel is dynamic and does the work. But fortunately, after taking the square root and finding the standard deviation, I then clue them in that Excel has a formula for doing all of that work for them. Usually I get a round of applause and a sigh of relief. So the standard deviation for the population, the formula is equals STDEV dot P for population. And the argument is the range of data. And for a sample, it's STDEV dot S for a sample, and it's calculated. And now you can see how nice that is if my data contains all of those. Well, now the average of that range is 49.5. The median is 45.5. Well, if I look for the mode of a single mode, it tells me 35. However, there are multiples of 35 and 65 that are occurring at the same level of frequency. And as you can imagine, with a database of hundreds of values, you don't want to have to count them. You don't want to have to go through all of this work. You want to use the built-in formulas. But I want to emphasize that I initially make them do all of this work so they have an appreciation for what it takes to calculate the standard deviation. Okay. This was an interesting problem that came from a business math course that I taught, where in an Excel file, the students had these categories for their account. And sales was a general ledger account called 4000. Accounting was a general ledger account called 5050, and so on. Banking service charges were 4010. Then they had this table, which they started the collecting information. For advertising and promotion, they spent $603.54. There was a banking charge of $15 that was entered into the ledger, and so forth and so on. But what they wanted to know is that in this row, where they entered that in their accounting ledger, what was the 603? It was a 3030 general ledger account. And of course, if it's a big ledger, we don't want to have to go figure it out. So now we go into a long explanation of how to calculate it. And Excel 365 has a feature, a function called filter. And if you think about it, filter says, I want to isolate and analyze and break down my data. So how would I filter it? It's almost like putting the data in the top of a funnel, and then based on criteria, it narrows it down and the answer drips out the bottom. So notice the filters arguments. The filters arguments are F2 to L2. Well, F2 to L2 are these account numbers in the general ledger. So what I want to do is that I want to filter F2 to L2, the general ledger account numbers. But how do I want to filter it? Notice that the tip tells me that filter requires an array as its first argument to be filtered. And then the criteria comes next as an argument, which tells me what things should I include. Well, what I want to include is when empty, that's quote, quote, is not equal to the body of data in the general ledger, which was from F5 to L5. So I'm including filtering the account numbers when the first entry in my general ledger did not have a blank in it. And of course, the first entry that doesn't have a blank in it is this one. So it's going to filter these and grab that one. And so let me get rid of all that junk on the screen. And come over here. And you see that I get 3030. And then what's really nice is that I can fill that down, and it now looks at the same general ledger account numbers, and it filters when the next row is not a blank, and when the next row is not a blank, and so on and so on. Okay, let's look at another case. Filter, very powerful new feature in 365. This is a fun example because we can look at the frequency distribution to see whether or not it skews left or skews right or looks more like a normal distribution. So what I've decided to do is to roll a pair of dice 100 times. So you can see that what I've written here is to select a random number between the range of 1 and 6. And so it picked a 2. Then I said, do it again. Pick an independent random number between 1 and 6. And it picked a 3, and so on. And if you look down in my data, whoo, it goes way down here, and there are 100 numbers. How did I know? Well, I counted how many numbers were in the range from A4 to A200. I didn't care that it was only down to 103. Then I did exactly the same thing here. I found the sum of them. And then I decided, well, the sum could range from 2 to 12. I could have used the sequence formula there. And I then wanted to know how many there were, how many 2s. So I used the function in Excel called count if the data, my array, my range from C4 to C103 matches what's in E4. That's a 2. And I calculate how many were 2s, how many were 3s, how many were 4s, and then I graph the frequency. Now, what I'd like to do is to take those 100 dice and roll them out again. So what I would like Excel to do for me is recalculate the roll. I can recalculate the formula by touching the F9 key on the keyboard. And now I've rolled it again. It's kind of looking more normal. There was only 1 2. There were 27s. That tells you why you don't go to the craps table. If I do an F9 again, I roll the dice again. It's kind of looking like a normal distribution. Notice that the 7 came out quite often. And if I F9 it again and again and again and again, it keeps rolling out the dice and showing me my distribution. Well, I hope I've given you a teaser of things to do in Excel in teaching math. What I'd like to do is see if you have questions in the 20 minutes remaining, or would like to address another topic, and I'd be more than happy to do that. And I'll let Victoria take over and tell me what questions you might have.
Thank you, Professor Weaver. This is wonderful and very informative.
Thank you. Are you going to do this now on your own?
Well, I do not teach math.
Or are you mathematically declined?
The latter.
Okay. Okay. Any questions?
We do have some questions in the chat. So we have from Professor Sargent. With the way that the dollar signs were used, I'm unsure how the Y values also filled in according to the sequence of X values. And he was referring to the quadratic example.
Okay, let me go back over here. Okay. So what was the question? Filling in here? What was the issue?
Sorry, I couldn't find my cursor. I was trying to unmute myself. Let's see. He was saying with the way that dollar signs were used, he was unsure how the Y values also filled in according to the sequence of the X values.
Okay. In Excel, cells are referred to by default called relative. Relative means when you put in a cell reference, for example, if I type in equals and this cell reference, that says in use B13 in the B17 position. So you see there it is. So what it did is that it put B13's contents in B17. When I look over here where I calculated the 380, think about what happens. One of the things I wanted to do was to take the number that was in F24. So what's in F24? That's the -7. That's X. And I wanted to square it. So F24 caret 2 squares it. Now, what did I want to do after I squared it? Okay, because powers come before multiply. After I squared it, I wanted to multiply it by the value that was in F22, which is the coefficient of X squared. That's the 6. Okay. Now, why the dollar sign? I'm going to go over here and show you what happens. I'm going to say, take this 6 and multiply it by this value squared. And you see there is 294. That's just the first part. And I can show that to you by going here, selecting it, and F9 on the keyboard gives you the interim solution. You see, it's sure enough 294. Okay. Now, suppose that I use the fill handle, which is that little gooby, that's a technical term for the little square, okay, on the bottom right corner of the cell. Notice that when I hover the mouse on that little gooby on the bottom right corner, it turns into a plus sign. And that plus sign says you can fill this formula. That works with a lot of things. I'll give you an example. Friday. Notice that little gooby's on the bottom right-hand corner of Friday. If I go put the mouse on it and drag it down, look what it does. It says, oh, I know what comes after Friday. It's Saturday, then it's Sunday, and so on. And it fills it down. By the same token, if I put in May, there's a little gooby there. It doesn't mean may I. It says, I think you're talking about the months of the calendar. And it fills it down. Okay. If I fill this down, watch what happens. I get an error message. Let's look and see what it did. It took the number that was in F25. Okay. So in F25, that was the -6. That's what I wanted. And it squared it and it got 36. I'll come up here. Hit the F9 key. See, there's my 36. And then it multiplied that by what is in F23. Oh, wait a minute. F23 has an X in it. You see, there's an X right here in F20. It can't multiply 36 times X, because what it did, just like it was adjusting the day, it was adjusting the month. When you drag it, it changed the F reference here from 22 to 23, just like it changed 24 to 25. But I don't want it to do that. Okay. The way you tell Excel not to do that is say, I would like F22 to absolutely, positively not change when I drag the formula down. And you do that by placing, and I don't know why they picked this, but they said, put $signs in front of the things you don't want to change. If I put a $sign in front of F, it will not change the column reference if I drag left or right. If I put it in front of the 22, it will not change the reference to row 22 when I drag up or down. And that's called an absolute cell reference. And watch, when I drag it down, I got the number I wanted because it says square that -6. Notice it highlights it to show to you. And then multiply it absolutely, positively by the 6 that's up in F22. So that's the purpose of the $sign. Okay. We have any more?
Thank you so much. We do. And Professor Sargent said he could see it now. So thank you for that explanation. He did share another question during the presentation. He mentioned, I could not find a way to get the quartiles to show up the way they do with the TI-84. I know there are at least 2 approaches, but I can't remember if there are names for these methods to help me search online. Is that something you could help with?
And so what did we want? What did he want or she want to show up?
So he's looking online for at least 2 approaches for the way that the quartiles showed up with the TI-84.
Oh, okay. For the quartiles. Okay. So without going into all the calculations, let me show you when you have an issue and you hope that there's a formula for it. You go to the ribbon and across the top, you'll see there's a home tab, an insert tab. This is all dynamic. Every time you click on one of these, the ribbon dynamically changes to suit that particular category. One of the things in the category is formulas. And there are over 400 formulas built in to Excel. So we could look, for example, under the formulas, let's say for math and trig, and look at them all. There's absolute value. And notice that when you hover the mouse on one, it gives you a little cheat sheet. It gives you a tip. This is arc cosine. When you hover the mouse on it, it tells you what it is. So if we're looking for quartiles, let's go down and see if we can find anything. Well, we don't have it, at least in this calculation, but maybe we have it in another one. Maybe it is statistical, okay? So we don't see that one showing up here in my choice of the function library, but there is one that's called more functions. And by golly, there is one called statistical. And if I then scroll down here and I get down into the Q's, there are the quartile calculations. And so, yes, you can do it. And there are calculations for ranking. You can look at percent rankings. You can do a Pearson calculation. You can do normal distribution. I mean, they've almost thought of everything. And if they didn't quite think of it, you can probably combine a couple to get one of them done. So you have to say to yourself, well, where would I find quartiles? Well, it's probably not a straightforward math or trig. It's probably statistical. So I'll look under more. And maybe if you're an engineer, you want to see what engineering calculations there are. Maybe if you're working in cubic varieties, you can look in there. There's all kinds of formulas, some 400 or more. I lost count. I don't know how many there really are. Okay, I hope that answered it.
Thank you so much. We do have another question.
Okay.
Miss Quartiles, I'm sorry if I mispronounced your name. She asked, what do you recommend when you give exams for your classes? Would this method require for students to take the exams online?
What do I require when they take the exam online?
I believe she's asking if you require your students to take them online, their exams online, or if you do take them, or if you do administer your exams in a paper pencil format.
Well, in the course that I teach currently in quantitative reasoning, the college has 3 campuses. They have a college, main campus is in San Diego, where I live. They have a campus in Chicago and a campus in New York. Not all students have to be on site at a campus. They actually call the online school another campus. So they theoretically say there are 4 of the campuses. So my students and my course is all online. There is no meeting face-to-face. In fact, I have some students that are not co-located in either of the 3 brick and mortar campuses. I have a student, for example, that lives in West Virginia, and she comes online to take my class. Now, she actually is taking this class, but not working on a Bachelor of Science in Public Health. She's working on her PhD in acupuncture, and the school has a PhD program in acupuncture. The only time, of course, that she's required to go on campus is if she's actually inserting needles into a human. So then she will go probably to the New York campus, which will be the closest, maybe geographically, from West Virginia. So the answer to the question is, because it's an online class, yes, they take the final exam online and they have access. I treat it as an open book course because their major is public health. They don't have to memorize all of this. So it's open book, open notes, and open Excel. So the exam is built around a database and they do work online when they take the exam.
Thank you for sharing your experience. And then we had just a few comments as well. Ms. Mouchon says she's so glad to see algebra applications, not just Excel and statistics. So thank you for your presentation today.
Sure, happy to do it. Great.
At this time, I did not see any other questions come into the chat or the Q&A. I'll just pause to see if anyone wants to enter anything in before we close up today.
My hope is that as a result of this, if you're teaching math, you will incorporate some Excel into the math so that the students don't have to do the laborious calculations. And it's even handier than working on a TI because you're limited on the TI to the amount of data you might be able to analyze. And it becomes rather laborious on a TI. But, as you can see, if I put this up on my screen, I have a TI-84 emulator that I use on my computer, and I can do calculations on the TI, which of course, if I turn it on, you can see that I can go under statistics and I have the ability to analyze a one variable set of statistics, and I can then calculate the standard deviation and so on. And of course, go down to calculating quartiles in item 7. But I can do it with a large database sitting in Excel.
Absolutely. Thank you so much again for your time and sharing your expertise. Everyone, I have shared in the chat a link for if you're interested in presenting for our Learning and Growing webinar series. Using that link, you can submit your proposals to our Learning and Growing website. And also, you can explore our other presentations that we have recorded there as well. Thank you so much, everybody, for attending. And thank you again, Professor Weaver, for your excellent presentation. And for everyone who has attended today, we will be emailing you a link to view the recording once it is available. And that way you can also share it with your colleagues. I hope everyone has a great rest of your day and good weekend as well.
Thank you. Have a nice long weekend.
Bye, everyone.